Hi guys, welcome back to the channel. My name is Jag, and in today's class with popular demand, we're going to continue with our Math 10 content. What we're covering today is going to be how to find the equation of a quadratic. Okay, so let's get started. So the question in the textbook is saying write an equation in the form of y equals ax squared plus bx plus c to represent each parabola. Okay, so it looks like they're giving us the x-intercepts here within the parabola. So let's write it out. So I have x equals 0 and x equals 6. Alright, and then they also give you 1 point that is on the parabola. Okay, so first we're going to put this into the factored form because I do have, so the general factored form, I have both of the x-intercepts. I'm going to put y equals a. Make sure you're changing the sign. So x minus 0. This is x plus 6, x minus 6. Okay, so this is my equation. And I'm actually always solving for the value of a. Okay, so let me give you the points that they have here. In the textbook, it's 5 and 5. So what you're going to do is take this point. I have the x and y terms. I'm going to plug it back into my equation. Okay, so the y is equal to 5. And then the x is also equal to 5. Just because the x-intercept is 0, that doesn't mean I'm not going to include it in my equation. Okay. And on this side, I have 5 minus 6. Everyone sees that so far? And you can see there's only one variable here, which is a variable of a, okay? The value of a is going to tell you whether the quadratic is stretched or compressed. So one more time, if the value of a is greater than 1, this is a vertical compression or a vertical stretch. And if the value of a is less than 1, like a fraction, it is going to be a vertical compression, okay? Alright, so we're going to try solving for the value of a here. This is 5 minus 0, 5. And in the second bracket, 5 minus 6, which is negative 1. Okay, so I can see 5 equals a times negative 5. Okay, to solve for the value of a, we're going to divide it by negative 5, okay, on both sides. And this is going to just cancel out here, okay, and we'll just write it on this side. So the a value is 5 divided by negative 5. Which is equal to negative 1. Okay, and remember after you find the value of a, I have to make sure I do restate my equation. So let's write it on this side. So therefore, my equation is y equals 1. Okay, and then it's x minus 0, and then x minus 6. Okay, I don't even have to actually write the 0 here. Okay, if I want, I can just write it like this, like y equals x, and then x minus 6. Which is basically the same thing. Even if the value of a is 1, there is neither a stretch, a vertical stretch, or a vertical compression. Okay, and the parabola basically is the same size as the parent function. Okay, does everyone see how to do that? Good. Let's try one more question here. Okay, I'm going to take this off. Okay, and again, I'm going to give you the x-intercepts. And what you're going to do is find out what this equation is. Okay. So let's try this one. So the x-intercept is negative 4. And the second x-intercept is equal to 6. Alright, and I'll put the point on the board after. Okay, let's put it into the equation. So y equals a. So you see how x is equal to negative 4. It's going to be x plus 4. And here again, I have x equals 6. Okay, change the sign. So x is equal to negative 6. So x minus 6 inside the brackets. Please make sure you do not forget to change the sign when you're putting it into the general form, the factored form, basically, of this quadratic equation. And if you don't change the sign, you're going to end up with the wrong answer. Okay? And now this is a point. So they always give you a point that is on the parabola. I have 1 and negative 5. Okay? I'm just going to use this point for x and y. And I'm going to plug it into my equation. Okay, so the point can be any point on the parabola itself. I can plug that into the equation and solve for the value of a. Okay, so here my value for y is negative 5. And my value for x is equal to 1. Okay, so you have 1 minus 6. So I can see wherever there is an x value, I'm just plugging in the 1. Whereas the y value is negative 5. Okay. Now again, there should only be one variable that I'm solving for in the equation. So in this case, it's going to be the value of a. Alright? So negative 5 equals a. And I make sure I actually just solve for each of the numbers within the brackets itself, because afterwards you can just multiply the numbers and it's very easy to simplify it. Okay, so we have 1 plus 4, so 5. And in the second bracket, I have 1 minus 6, which is equal to negative 5. Okay, so negative 5 equals 8. And 5 times negative 5 is negative 25. Okay, again, don't worry if the value for a is a fraction. Okay, you could just leave it as a fraction, but make sure you do simplify it. So in this case, I'm going to divide by negative 25. Okay, on both sides, so it cancels out. Okay, and if you look on the left side here, I have negative 5 over negative 25. We're going to reduce that. The value for a is positive 1 over 5. Okay, everyone sees that? So you don't need to actually box your answer here because I want to make sure I write the final equation. Okay, so we'll put therefore the y equals to 1 over 5 x plus 4, okay, and x minus 6. So this is my final equation. So I'm going to box my final equation actually. Okay, I'm just going to move this up so everyone can see it. So this is x minus 6. Okay, so this is actually my final equation here. And you can see the value of y is 1 over 5. Again, if you're checking 1 over 5 on your calculator, it's equal to 0.2. Okay, and because 0.2 is less than 1, I know that this is going to be a vertical compression. So one more time, make sure you don't get confused. Even if the actual value for a is a fraction, like say again it's 3 over 2, you're doing 3 over 2 on your calculator. This is 1.5, okay? So it's not just that it's a fraction, it has to be a fraction that is less than 1 in order for it to be a vertical compression, okay? Does everyone see how to do that question? So with that, let's try one last question here, okay? I'm just gonna see if the question is different. Okay, so let's try this one. Okay, it looks just about the same. Okay, so this is the section that we are covering in terms of the factored form of the quadratic. Okay, and that's why you can see that each of the intercepts have to be given, okay, in order for me to actually solve for the quadratic equation here. Okay, so let's try this one here. Let me give you the x-intercept. So x equals negative 8. Okay, and x equals negative 2. So these are my x-intercepts here. Okay, let's put it into the equation. And this is the general factored form of the equation. Okay, so I have x equals negative 8. I'm going to change it. So x equals positive 8. I have x equals negative 2. In brackets, I'm going to put x plus 2. Does everyone see that? Okay, and you should always be doing at least 2 or 3 steps, okay, when you're solving for the equation of the quadratic. All right. And again, I'm just going to plug in my point right here, which is negative 7 and negative 10. Okay, actually for like the last 2 examples, I did leave the example in the factored form. Okay, for this one, we're going to actually expand it out, okay, because it's saying to write the equation in the standard form here, okay? So it looks like we have to do a couple of extra steps. All right, so let's plug in our values. So y is negative 10 and the x is negative 7. So wherever I see x, I'm putting negative 7 here. Okay, yeah, so it's negative 7 and negative 10. Okay, I'm going to solve inside the brackets first. So a, negative 7 plus 8, positive 1. Okay, and then negative 7 plus 2, which is negative 5. Everyone sees that? So on the right side, I'm just doing 1 times negative 5, which is negative 5. And we're going to divide by negative 5 on both sides, just so it cancels out. And I have the value for a. So a is negative 10, okay, divided by negative 5, which is equal to positive 2. Okay, so I'm just going to box that. Okay, so everyone can see it. And let's write our equation at the top, okay? So the equation is y equals 2. And it's going to be x plus 8, and then x plus 2. Okay, so this again, just like we did the other 2 questions, this is in the factored form, but we should be changing it back into the standard form. So it depends on what the question is asking. A lot of the times the teacher will just ask you to find what the equation is of the parabola. And if it's not specified, I can leave this as my final answer. Okay? So, but in this case, it does say write an equation in the form of y equals ax squared plus bx plus c to represent each parabola. Okay? So if you look at this general equation, this is actually the standard form of the quadratic. Alright? So I'm going to just take off part of this here. Okay? And what we're going to do is we're going to use our equation here and just like expand it out. Okay, so let's write it at the top. So I have 2x plus 8 and then x plus 2. Okay, so this is just a little bit of, let's use our FOIL method. Okay, and that's what we're going to use to expand this out. What I like to do is if there's a number outside the brackets here, I always keep it on the outside until the very end. Okay, so let's just FOIL out the inside brackets. So I'm doing x times x, so x squared. Okay, then you're going to go to the next two terms, x times 2x, or x times 2, so it's positive 2x, okay? And again, make sure you're always foiling out these binomials in the same pattern, okay? And that way you know that you're getting the right answer. Then I'm going to do the middle one, so I'm putting numbers here, okay? So 8 times x, which is 8x. And lastly, we're going to do 8 times 2, which is positive 16. And you can see it's easier to basically do the binomials and FOIL that out first, okay, rather than you putting the 2 into the mix there. Okay, so leave the 2 outside until the very end. I'm going to collect the like terms in the brackets here. So I have 2x plus 8x, positive 10x, and then positive 16. Okay, and this will be the last step here. Okay, this is going to be in the standard form. Okay, so I'm going to put y equals, and then I'm going to just use the distributive property and distribute each of these terms out. So 2 times x squared, 2x squared. And we're doing 2 times 10x, which is 20x, so positive 20x. Okay, and then 2 times 16 here, which is equal to 32. Okay, so this is positive 32. Okay, so right here, what we have on the side here, this is actually the standard form, okay, of the quadratic equation. And if you look on the right side, okay, this is, let me write it on top, this is actually the factored form, okay, of the quadratic. However, if you look at them both very closely, you will notice that this is basically the same equation. Okay, make sure you're very comfortable changing from one form of the quadratic equation into the other form, because that is actually very important. And that's again the only way the teacher can try and trick you. So say I just stopped right here and I'm actually supposed to write the quadratic in the standard form. The teacher will take off marks for that, okay, on a quiz or a test. So just keep your eyes open there. Make sure you're changing from one form to the other. All right. If you're not sure, I would make sure I do, again, a lot of practice questions from the textbook just to reinforce this concept. All right? Okay, so that looks good. If there are no questions, that does bring this video to an end. Thank you for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks. Bye.